Welcome to this explainer. Today, we're looking at one of the most deceptively simple pieces of equipment in the entire oil and gas industry. We're talking about a completely mundane object doing an incredibly extreme job. It's a piece of hardware with literally zero moving parts, zero electronics, zero backup, and yet every single thing happening in a well absolutely depends on it. Okay, let's dive right into this. Imagine picking up a standard metal bucket full of water. You don't grab the bucket itself, right? You grab the handle. Well, that handle is called a bale, and it's actually been called that for centuries. Now, I want you to scale that exact handle up in solid, forged steel until it's carrying roughly 500,000 pounds of drill pipe just hanging over an open hole that's 2 miles deep. It's got the exact same name, and it does the exact same job. There is absolutely zero glamour to this massive piece of equipment, but it is an absolute necessity. It's quite literally the bucket handle of the rig. If it fails, everything below it is lost for good. So, we really need to break down exactly what this massive piece of equipment is and why it matters. Today, we're going to cover what is a bale, the load path, matched pairs, and finally, fatigue and failure. Formally speaking, a bale is a large, cylindrical steel bar that supports the swivel and connects it to the hook. It's a pure load-carrying link. But if you contrast this dry academic definition with our casual bucket handle analogy, you really start to see how its function is simple, but just terrifyingly critical. Its entire purpose in life is to transfer immense weight from one component to the next without snapping. Nothing more, nothing less. Section 1. The load path. Chain of hoisting links. To really appreciate this, you've got to understand that rig hoisting is literally a chain of links, and the physical load flows through every single component in an unforgiving series. Let's move to and see how this builds. Check out these 5 steps. You've got the drill string hanging from the swivel. The swivel hangs from the bale. The bale hangs from the hook, and the hook hangs from the traveling block. If you fail any single link in this chain, everything below it goes straight to the bottom of the hole. This visually proves that the bale is a non-negotiable bottleneck. It carries the full string weight all the time. Moving on to Section 2, matched pairs and rig configurations. What's really interesting here is how we actually apply these bales out in the field across different types of rigs, because depending on what rig you're looking at, the configuration changes entirely. On a traditional rotary drilling rig with a Kelly, you'll typically see one massive bale carrying the swivel. But jump over to workover and servicing rigs or pulling units, and you're almost always going to see bales utilized in matched pairs carrying the elevators, one on each side. The reason for the pairs is simple but totally essential. It ensures the pipe hangs perfectly level while it's being handled. Now, while modern top drives have largely replaced this single bale arrangement on drilling rigs, on every pulling unit and workover rig in the world, bales are still out there handling pipe every single day. Which brings us to the incredibly strict rules governing bales. See, bales are rated in tons. Common classes are 150, 250, and 500 ton. They have to match or exceed the rating of the hook and elevators they work with. But when you're using matched pairs, there is an absolute, non-negotiable requirement. They must be identical in length and rating, pulled from the exact same set. So let me ask you this directly. Imagine you're rigging up a pair of bales, and one of them is just 2 inches longer than its partner. Just 2 inches. Does it actually matter? I mean, 2 inches seems like a tiny rounding error on a rig where loads are measured in hundreds of tons and depths are measured in miles. It absolutely matters. So the crucial point is that unequal bales tilt the elevators right off horizontal. A tilted elevator doesn't grip the pipe shoulder evenly. Instead, all that load concentrates entirely on one side. Under that kind of tension, the pipe can literally jump right out of the elevators. Just 2 inches of mismatch is enough to drop a string, turn your well into a massive fishing job, and cost hundreds of thousands of dollars. That is exactly why they're sold, used, and inspected as matched sets. Which brings us to Section 3, fatigue and failure, where bales actually break. If we know how much weight they carry, we definitely need to know how they break. The threat here usually isn't a sudden snap from pure weight, it's the silent, invisible killer of rig hardware, metal fatigue. And we know exactly where it loves to hide. And this brilliantly illustrates the point. Think about carrying heavy groceries. A shopping bag never tears in the middle of the strap, does it? No, it tears right where the strap bends over your hand. Well, bales are exactly identical to that shopping bag strap. The straight sections of the steel bar are barely stressed at all. All of the physical punishment concentrates in the curved eyes at each end, right where the metal physically bends around the hook and the swivel. These curves are bent and reloaded thousands upon thousands of times, hiding microscopic, invisible fatigue cracks right at the inside of the curve. Because these cracks start at the inside of the curve where the stress concentrates, a crack there is completely invisible to the naked eye until the exact day it fails. No warning. That's why the American Petroleum Institute requires periodic inspections specifically using magnetic particle testing. When an inspector checks a bale, they don't waste time wandering along its straight length. They go straight to those two curves. That's the only place worth looking hard because that is exactly where it's going to fail. To wrap up the core takeaways of this explainer, a bale is a pure load-carrying link that transfers massive weight. When used in pairs, they absolutely must be perfectly matched to prevent dropping the string. And because of metal fatigue, you always have to aggressively inspect those curved eyes. It's a remarkably simple, zero-redundancy part acting as the ultimate lifeline for the entire well. We walk past simple things on a rig floor every single day without a second thought. But if the simplest part of the rig, a giant metal bucket handle, holds a 500,000-pound secret and requires magnetic particle testing just to prevent catastrophic failure, what else are you walking right past? Keep that in mind and join us for our next explainer as we continue to uncover the hidden stakes of everyday equipment.